All right, first one here, solving a system with a non-linear term. So all that means is we are going to solve for either x or y for the second equation and then go ahead and plug that into the first equation to solve. So I'm going to pick the second equation here, solve for x. I get negative 3y minus 4. Okay, then I'm going to take that and I'm going to plug this in where I see x. So I'm going to have 3 times negative 3y minus 4 squared minus 2y is equal to 5. Okay, from here I'm going to go ahead and factor this out. So I've got 3 times 9y squared plus 24y plus 16 minus 2y is equal to 5. Then I'm going to go ahead and distribute here. So I get 27y squared plus 72y plus 48 minus 2y equals 5. And now I'm going to get everything over to one side here. So I've got 27y squared plus 72y, actually 70y if I combine those, and then plus 43 equals 0. And now from here, I would not even think 2 seconds about trying to factor it. I would plug this into your calculator. So go ahead and polymelt 2. You can go to the root finder, plug this in, and you should get 2 answers of negative 1 and negative 1.59 approximately. And then once we've got those 2 answers, we're going to take and plug those into my equation for x. Because when I'm solving a system, I should have a coordinate. So I'm going to plug this value of y in to give me x equals negative 3 times negative 1 minus 4. And that should give me x is negative 1. Same thing if I plug in y into that equation, I end up getting y is equal to 0.77. Now, when we solve for a system of equations, we should always write our answers as a coordinate. So don't forget, final answer, I want negative 1, negative 1, and, I wrote y equals, but I meant x equals. 0.77, negative 1.59. So those are my 2 answers for this system of equations. All right, next one here. Again, it's a system of 3 equations this time. You have to show work for credit, but we can use our calculator to solve for this as well. But we're going to do it the long way first. So I'm looking to get rid of a variable. I'm probably going to get rid of my z's because they just look easiest to get rid of. So I'm going to add these 2 together first. When I add those 2 together, I end up with 3x plus 2y is equal to 4. But then I also need to add these 2 equations together so that I can get rid of z as well, which means I need to multiply the second equation by 6. So I'm going to rewrite my 2 equations here. 3x plus 9y plus 6z equals 3. And then I've got 12x plus 6y minus 6z equals 12. Add these 2 equations together, and I get 15x plus 15y is equal to 15. So now I have 2 equations with 2 unknowns, so I can solve this system by moving this over here. And I am going to multiply this top equation so that I can get rid of a variable. So I'm going to multiply by negative 5 so that I can get rid of my x's there. When I multiply by negative 5, I get negative 15x minus 10y is equal to negative 20. So I can add these together. The x's go away. I'm left with 5y is equal to negative 5, which means that y is equal to negative 1. Now I know that y is equal to negative 1. I can go back and plug this into either of my equations that have just x and y. And when I go back and plug that in, I'm going to plug it over here. I can solve for my x. To give me 15x is equal to 30 and x is equal to 2. Almost done. We got one more variable to solve for, so I can pick any of my equations back from the beginning, plug in x and y, and solve for z. So I'm going to go ahead and choose this last equation here just because it'll be the easiest to plug in. So I've got 2 plus a negative 1 plus z is equal to 2, which means 1 plus z equals 2, so z is equal to 1. And again, final answer should be written as a coordinate. So as a coordinate, this should be 2, negative 1, and 1. Now again, like I said, you can go into PolySmelt 2 on your calculator, and this will be simultaneous equation solver that you want to go into, and you're going to choose 3 equations and 3 unknowns to solve for this system of 3 equations. Okay, so you can do that at another time. I'm going to go ahead and move on. The third type of graphing problem that you will see on your final is graphing a system of inequalities. Okay, so things that might be helpful to put on your note card, and if you need an extra note card, I've got some extra up here. You can come grab at some point. But if I have less than or greater than symbols, that would have a dashed line. If I have less than or equal to, greater than or equal to signs, that would be a solid line. And then we do have to remember to shade. Okay, so test a point and shade either where it's true or where it's false, depending on which one you're testing. Okay? So starting out, I'm graphing the line y equals 2. So y equals 2, this would mean it's a solid line going through the point y equals 2. Okay, if I test a point, I'm going to test the point 0, 0. If I test the point 0, 0, is 0 greater than or equal to 2? No. So I'm going to shade on the opposite side of where 0, 0 is. Okay, next is a circle. This is a circle, and it's going to be centered at 0, 0 with a radius of 3, the square root of 9. So I'm going to start 0, 0. I'm going to go up 3 on both sides here to make my circle. And then I need to decide, am I shading inside the circle or outside the circle? So I'm going to test the point 0, 0. If I plug in 0 here, is 0 less than or equal to 9? Yes, it is. So I can go ahead and shade everything in the center. And then the last one I've got is this is going to be a line. So if I solve for y, I have y is less than negative 2x plus 1. So that means I start up 1 on the y-axis here, and then this symbol tells me it's going to be a dashed line. So I'm going to go up 2, left 1, and I'm going to have a dashed line in between all those points. And then we got to decide where we're going to shade. So if I test the point 0, 0, 0, 0 is 0 plus 0 less than 1. Yes, it is. So I'm shading everything below this line, which means that my solution to this system of inequalities, and this is where on your test you're going to want to make sure you're careful and you're showing me exactly where that is, because this overlapping piece is right here. That is my solution to the system of inequalities. That's the part that's being shaded by the red, the blue, and the black piece there. So that is my answer to this linear inequalities. Actually, not linear, but just system of inequalities. This next one, we're just going to set up the equation and show you how you can use your calculator to solve it for you, because the one similar to this on your final, you will not actually have to show your work for it, but you will need to solve it and get the answer and choose from the options. So we've got a bank that's consisting of nickels, dimes, and quarters. There's 45 coins in total, valued at $3.80. The number of nickels is 7 less than 3 times the sum of the number of dimes and quarters together. How many dimes are in the bank? So let's go ahead and define some variables here. I'm just going to call nickels X, dimes Y, and quarters are Z. So if I have 45 coins in total, that means my first equation is just going to be X plus Y plus Z is equal to 45. Now those 45 coins total up to give me $3.80. So that means I need to assign some value to what those X, Y's, and Z's are. So X would be 0.05X plus 0.10Y plus 0.25Z. And that's going to be equal to my cost of $3.80. And then this last one's a little tricky. So we know that the number of nickels is, so we're going to say X is equal to, let's kind of work backwards because it says 7 less than 3 times the sum. So let's do the sum first. It says the sum of the number of dimes and quarters together. So the sum of quarters and dimes together would be Y plus Z. But then it says it's 3 times that. So I'm going to put a 3 in front of the Y plus Z. And then lastly, it says it's 7 less than all of that. So I'm going to have minus 7 after all of that stuff. If I go back and read it, it should kind of make sense. This is the number of nickels is 7 less than 3 times the sum of nickels and quarters together. So now on your calculator, you cannot go into Polysmelt 2 simultaneous equation solver and just solve this right now because it's not in standard form. It has to be in standard form, which means these first two are, so these are fine, but this last one I need to have my X's and Y's on the left-hand side. So let's go ahead and do that. If I solve or distribute this, I get 3Y plus 3Z minus 7, and I can subtract those things over. And now I have 3 equations, and those 3 equations are in standard form, and we can plug that into our calculator to evaluate our question, which says how many dimes are in the bank. So which letter am I actually solving for when you get an answer? I'm solving for Y, okay? I don't remember exactly what the answer is, but you guys can test that, plug it in your calculator. I am going to move on. Okay, partial fraction decomposition might be a good thing to put on your note card if you're thinking of what you could add to it. This is kind of a table setup to help you remember how do your fractions go. So if you have just linear terms on the bottom, you're only going to have constants up top, a and b. If we have a quadratic, x squared is quadratic, okay, and then I'm going to have an ax plus b term, or I'm going to have 2 terms, one with an x and one just constant on top. But my linear term will just have a letter. If it's a repeated linear term, so that means it's the same term twice, we write it once for the first fraction and then twice for the second fraction there. And then lastly, if I have a quadratic and it's also squared, I would write it once and then I would write it squared. But both of these would have ax plus b on top, cx plus d on top, because I've got an x squared term on the bottom. Okay. So we're just going to go ahead and we're going to skip A, but we're going to do B. I do believe the one on the quiz, on the test, will be factored for you already, but that would be the first step, is to factor the denominator. So the denominator is already factored here, so I just need to write my partial fraction composition out. So the first term is linear, so on top I would just have A. My second term is x squared plus 2. So in the numerator, it would be bx plus c, because I've got an x squared term there. And then I am multiplying this entire thing by the least common denominator, or x plus 1, x squared plus 2 in this case. Okay, so when I multiply this, I take this whole thing and multiply it by my first fraction there, which is going to get rid of the denominator completely. So I'm going to have x squared plus 3x minus 1. And that's going to be equal to my second fraction, a over x plus 1 times x plus 1, x squared plus 2. So that's going to give me a times x squared plus 2. Then we got to be careful on the last one. This last one here, we're going to have bx plus c is in parentheses. And then the x squared plus 2's go away, and I'm left with just x plus 1. Okay, once I do this, I just have to pick some values for x so that I can solve for a, b, and c. So let's say if I pick x to be -1, that's going to get rid of both my b and my c. So let's do that. X is equal to -1. If x equals -1, I plug that in on the left-hand side. And when I plug that in on the left, in red there, I get -3 is equal to a times -1 squared plus 2. And then everything else goes away. So now let's just simplify this. I've got -3 is equal to a times 3. So a is just equal to -1. Now I gotta choose something else for x. Another thing smart to choose for x would be, how could I get rid of the b there? 0. Let x be 0. So if I if I let x be 0, I can get rid of b. So on the left-hand side, I would have -1 is equal to, I know what a is equal to now, so I can put that in, times 0 squared plus 2, so times 2. And then plus my b goes away, but then I will still have c times x plus 1, which is just 1 in this case. Go ahead, quick solve here. This gives me -1 equals -2 plus c. So c is equal to +1. And then lastly, is it going to matter what we choose for our third one? Nope, I can pick any number. I'm just probably going to pick 1 because that's an easy one to plug in. When I pick 1 and I plug that in on the left-hand side, I get 3. And then I plug in my a value, which is -1 times 3 plus my b value, I don't know, so b times 1 plus c, and then x plus 1, so that would be times 2. So if I simplify this, I get 3 equals -3 plus b plus 1 times 2. I add the 3 over, I get 6 is equal to b plus 1 times 2. And I can either distribute that 2 or I can just divide it out. I'm just going to divide by 2 on both sides. And that gives me that 3 is equal to b plus 1. So b is equal to 2. Now, when you're choosing your answer, this is not just going to say a is equal to this, b is equal to this, c is equal to that. It will give you your final answer in terms of your partial fraction decomposition. So it would look like this as an option. -1 over x plus 1 plus 2x plus c over x squared plus 2. That would be the multiple choice question or answer that you would choose for this problem. Okay, difference quotient. This would be another good formula to have on your note card here if you want to add that to your stuff to have on your test, because all you really need to do is follow that formula. The formula says f of x plus h. That means if I look at this first formula here, if I'm trying to find the difference quotient, I'm going to plug in x plus h where I see x's. So I'm going to have 2 times x plus h squared minus 3 times x plus h. Then it says minus f of x. Well, f of x is equal to this whole thing. So I'm going to subtract 2x squared minus 3x. And I'm going to divide all of that by h. And then all you have to do is simplify it. Okay? So we're going to have to do a little bit of factoring here. When I factor this first part, I'm just going to also distribute the 2 with it as well. I get 2x squared plus 4xh plus h squared minus 3x minus 3h. And then distribute that negative minus 2x squared plus 3x. And all that is divided by h. So now you should see some things that can cancel, like my 2x squareds can go away, my negative 3x's can go away. And now I'm just left with 4xh plus h squared minus 3h all divided by h. Now I can take out an h out of every single thing here, so I'm going to divide all these by h to give me my final answer of 4x plus h minus 3. So as long as you have this formula here, maybe put an example on your note card if you're struggling with this one. But that should be it. I'm going to skip example 2 so we can move on and give you guys some more time to work. Okay, that was all of Unit 3. Any questions on Unit 3? Okay, Unit 4 is what we just did, so we're going to kind of zoom through this. I'm only going to go through like the first 2 to 3 terms of the first part here, just to save us some time. So it says write the first 5 terms of the sequence. This first one, all you're going to do is plug in 1 through 5, and that's your value. So like a sub 1 is equal to 1 plus 1 over 1 plus 2, which is going to give you 2 over 3. If I plug in 2, I'm going to end up with 3 over 4. Okay, all the way up to 5. Again, on your test, this is going to be multiple choice. So you're going to choose the answer that has the correct 5 in the correct order. Now, letter B is using the recursive formula. Okay, the recursive formula says I'm going to take the previous term and plug that in where it says a sub n minus 1. Okay, so if we look at this example, it says a sub 1 is 4. So that's my first term automatically. My second term, if I follow this formula here, that says it's 2 times a sub 2 minus 1 plus 1. Well, that's the same thing as 2 times a sub 1 plus 1. And we know that a sub 1 is equal to 4, so I can plug that in here. So this is equal to 2 times 4 plus 1, which gives me 9. But if I'm doing a sub 3, I'm not also going to use 4 this time. This time I'm going to end up using 9. This is my previous term. This is a sub 2. So I'm going to plug in a sub 2 for a sub 3. So this is 2 times 9 plus 1 gives me 19. So you're taking your previous term, plugging that in to evaluate your answer. Okay, these two, you can just literally straight up plug into the calculator. You don't have to show any work for these, but you do need to make sure that your calculator gives you the right answer. So you should get, I'll give you guys a second to try it out. We should end up getting, for the first one, 132. And for the second one, you should be getting 409,112. Remember, this whole thing needs to be in parentheses. And if you don't remember to find the factorial button, you go to probability and then option number 4. Okay, so try that out real quick and see if you get those answers. All right, next ones, I'm just going to kind of pick maybe 1 or 2 of these to do because we just had this unit over arithmetic and geometric sequencing. I would say, however, for your difference, you might want to add this little kind of formula to your note sheet. Same thing with your ratio, because that's not on your gold sheet for terms that are not right next to each other. So you might want to add that onto your note card or your gold sheet. Either one would be fine to add that to, okay? So let's do, for this first section of arithmetic sequences, we'll do the first example, find a sub 1 for the arithmetic sequence that has a sub 8 being negative 16 and a sub 16 being negative 40. So what we're going to do is we have to first find the difference, and these terms are not right next to each other. So I'm going to use that formula. So I'm going to subtract negative 40 minus negative 16, and I'm going to divide that by 16 minus 8. And if we plug that in our calculator, simplify it, we end up getting negative 3. So my difference is negative 3. Now that I know my difference, I can go ahead and take that information and plug it into this formula here and solve. I can either pick the first or the second one, it doesn't matter. I'm going to pick a sub 8, and I'm going to plug in that information. So I've got to have negative 16 is equal to a sub 1, which we don't know, plus 8 minus 1 times my difference, which is negative 3. If I evaluate this, I get negative 16 equals a sub 1 plus 7 times negative 3, so that gives me minus 21. So that means a sub 1 is actually equal to 5. Okay, if it asks us to find a sub n, we would just plug in a sub 1 is 5, and my d is negative 3, and then the n's would stay there for a sub n. Okay, I am going to skip this next one, but if you do want to try it at some point for extra practice, the answer for A1 is 35, and the answer for D is negative 3 again. Okay, and then for this one, we'll skip the first one and we'll do the second one. So your first one, if you want to try it at some point, your R value is 2. And A1 is 5. And then I'm going to go ahead and do letter A. We'll skip letter B. Okay, so these are two formulas that are on your formula sheet as well. The sum of the first n terms and the sum of the infinite geometric sequence are given by these two formulas right here. And so I need the first term and the rate if I'm trying to find the infinite sequence, or the infinite sum, I guess I should say. So I want to find my first term, so that means I'm going to plug in positive 1 to find my first term. So I've got negative 3/4 times negative 1/2 to the 1 minus 1 power. I just plugged in 1 for I, which that's going to give me 0 here, and anything to the 0 power gives me 1, right? So this goes away. And my first term is negative 3/4. So that is a sub 1. Your ratio or your rate is always the thing that is right next to the exponents. So negative 1/2, that is my rate. And now we're just going to follow this formula here of a sub 1 divided by 1 minus r. So a sub 1 is negative 3/4. And I'm going to divide that by 1 minus r. And do some simplifying. Negative 3/2 divided by, that would be the same as 3/2 because you add them together. And that's the same thing as multiplying by the reciprocal. So my answer is negative 1/2. If I did that right. I do believe so. It just so happens that our ratio there ends up being our answer. That will not always happen though. Last stuff real quick, permutation combination. There's your chart again from your notes, but remember the most important thing is remembering that permutation is order matters, okay? Combinations order does not matter. So just quick 2 examples. There will not be a lot of this on your final since we did just go over it and you guys just took a test over it, but there will be a few. So the first question here says, how many different ways can you have a committee of 4 being selected from a club of 22? Okay, so does order matter there for this? Nope. So I know it's going to be a combination. So on your calculator, you're just going to do 22, choose 4. And when you do that, you should get 7,315. And then there will be a license plate problem on your test. There will not be a family problem on your test or one of those double dice ones. There won't be one of those. But this license plate one, it says it's made up of 3 letters and followed by 2 digits. Determine the number of possibilities if no letter or number can be repeated and the letters X and Y are omitted. Okay? So if I can't repeat letters and I can't use X and Z, how many letter options do I have to start with? 24 options. Okay, the next option I would only have 23 options, followed by 22 options. Okay, because I can't repeat, it says. And then there's no restrictions on digits other than the fact that I can't repeat the digits. So my digits would start with 10 and then go down to 9. And you're just going to multiply all these things together. And when you do that, you get this big number of 1,092,960 different ways to make those license plates. And then the last thing is the binomial theorem, also on your gold sheet, will be multiple choice on your final. All you got to do is pick the correct answer. So we are going to expand this 3x plus 5 to the third power. Always start with your exponent is 3 in this case. So I've got 3 choose 0 times my first term, which is 3x to the power of 3. And then that would be times 5 to the 0 power. And then we just work our way down. The first exponent goes down by 1. The second exponent goes up by 1 until we get to 3. So I've got 3 choose 1 times 3x squared times 5 to the first power plus 3 choose 2 times 3x to the first power, 5 to the second power, and then 3 choose 3 times 3x to the 0 power times 5 cubed. Okay, now on your final, this is going to be multiple choice, so you are going to probably need to simplify it to find your correct answer. We know from the Pascal's triangle, or by plugging it in the calculator, these are going to be 1, 3, 3, and 1 for those combination parts. And then you might need to simplify it fully to see your final answer. So 3x to the third, that would actually be 27x to the third. But 5 to the 0, that just goes away. It's 1. And then 3x squared is the same as 9x squared times 5. Then I would have 3x to the first, so times 3x, and then 5 squared is 25. And then lastly, 3x to the 0 is 1, but 5 to the third would be 125. So I can simplify this one more time to give me 27x cubed plus, let's see, what does this give me? 135x squared plus 225x plus 125. And then the last one is finding the rth term, so finding the fourth term of your expansion given a plus 2b to the 12th power. Again, you can follow this formula, which is also on your gold sheet, and just plug in all that information. So it starts with the exponent up top, so 12 choose the fourth term, so 4 minus 1. Then I take my first term of a, and that's going to be to the power of these two things subtracted. So 12 minus 3 would give me 9. And then that means my second term of 2b is going to be to the power of 4 minus 1, which is 3. And then we just got to simplify this. This is 12 choose 3. So on our calculator, if I do that, I get 220 times a to the 9th times 2b to the third would be the same thing as 8b to the third. And so your final simplified answer, 220 times 8, that would give you 1760 a to the 9th and b cubed. Okay, bunch of information thrown at you. That's units 3 and 4 in a nutshell. Make sure you guys get that summative, or not summative, but the finals review done. You guys have until Friday at 1 to get that turned in. If you see any mistakes on the answer key, please let me know. And if you have questions, please let me know. You guys have the rest of class to work on it.